Kotlin has many built-in types. Let's go ahead and explore the number types. The lowest number type is a byte. So I'm going to create a variable called myByte, and it's of type byte. And I'm going to set it to a value of 8. Bytes are equivalent to 8-bit signed integers. The next one up is a short. So I'll call this one myShort, and we'll explicitly provide the value of short. And I'm going to set this one value to equal to 16. And this is a 16-bit signed integer. So as you can see, as we move up, the numbers are going to get bigger, meaning that the values that they can store are going to be bigger, which brings us to the most popular probably in regards to programming that you see, and that's going to be the integer value. And this is going to be equivalent to a 32-bit signed integer. Next up, we have a long. Now, a long is a very long number, so it's kind of a good name for it. It's a long number that you could use. And that's going to be equivalent to a 64-bit signed integer. Now, these are going to be the most common types that you use when you're working with numbers. So you're going to be using these. And most often, you're going to probably be using an integer value, as it will cover 90% of your use cases. If you need to use a long number, which is very long, then you want to use a long. And there's times when you do want to use that. Perhaps you're storing numerical values that that are very lengthy. However, there are also times when you do need to store decimal values. So if you do need to store decimal values, there's also something known as a float. And so we'll say like this, a float. And we're going to say this one is equal to 32.00. And I'll put an F here because that means in literal terms that this is a float. And what this thing is equivalent to is a 32-bit floating point number. So this is a smaller decimal we can use. Now, if you need to use a larger decimal, you're going to use a double. And that's going to be called double, and that's equivalent to 64. And that's going to be a 64-bit floating point number. So these are kind of the basic numbers that you're going to use inside of your day-to-day application development. Now, there's something interesting about each one of these. If we go to the definition of any of these, and I'll start with byte, we can see that byte extends number. We can also go back to the previous file, short, and we'll look at that. It also extends number. And as we walk down each one of these, you're going to notice that every one of them, from integer to long to a float to double, etc., all of them implement the number abstract class. So let's go take a look at that again. What does that look like? If we go to the number implementation, we'll see that it has a bunch of functions on here that we can access, which is interesting, which means if we go talk about this for a second, that every type, every object, everything in Kotlin is an object. So even this integer value is an object. This long is an object. This byte is an object, which means that we can call methods and properties on these. So if I want to print ln the myByte dot, perhaps I wanted to perform division operation. There's a bunch of math operations you can perform on here. These are built into there from the various different types. If I want to say to double, I could say to double, and that would turn my byte into a double. And this actually comes from the number class. Remember, if we go to the parent declaration, which was command U, we can see that this came from to double. And so it returns a double. And so it would take this byte and turn it into now a double. So if we were to print this, and let's get the type information by providing : class, and then running it, you would see that it does return a double. Now, if we were to come over here, we could actually change this to a long. We could run it again, and you would see that it returns a long. So there we go, 8. And we forgot to provide the values there. Say class, run it again, and we'll see that we now have class kotlin.long. When working with certain numbers, such as longs, we can take and we can use the literals. And we can say big long, we can say this is a long value, and then we can actually do some cool syntax. And so what this does is it's built-in syntax to Kotlin that makes it easier to read. So this is equivalent to 1 million. So if I were to print line, and and we were to print this big long in here and run it, we would actually see that this is just going to print out as 1 million, but it makes it just a lot easier. These underscores do, because you can read it. This is very valuable if you have a constant in your application that you know is always going to be 1 million, or it's always going to be 1,000 or something like that. You can make this a lot easier to read, because let's say you're going to go for 1 billion. This is much easier to read than this, because you're not sure by looking at this if is that 1 billion or is that 100 million. It's really hard to tell, but just by adding these simple separators, we can actually tell real easily that that would be 1 billion. One of the additional things that we can do with numbers is we can, of course, add them together. So we could say my int, we'll say new int equals my int plus 12, and that would equal 44, but we can print that to the screen and say new int, and when we run this, we'll see down here in the bottom that we're going to get 44 right there. But we can also do an additional thing by using the built-in methods. Plus, we could say 12. Now we could run that here. So there's some nice syntactic sugar to say plus, we're gonna get 44. We can also do minus. We can run this, and you'll see that we also get 44. There's a bunch of other math operations that we can inspect inside of here by simply providing the dot to get the code completion and implement them. And so if you're not familiar with much of these, you can hop into there. And let's say, for example, you're not too familiar with the word and is. You could take Command B and go to that and say it would perform a bitwise and operation between these two values. So if you want to do bitwise math, you could do that with the and. You could add plus. You could do multiply times. And then you could run that. So 32 times 12, it's going to run here. We'll have 384. And so these are the basic types from smallest to largest. You're going to start with byte, short, int, long. And then when we get to decimals, you have float and you have double. These are the built-in number types in Kotlin.